questions 21 to 25 on the 2005 Grade 8 AMC 8. How many distinct triangles can be drawn using 3 of the dots below as vertices? The first thing I want to do is label these in terms of numbers. It makes it easier for me to explain what triangle I'm drawing. So the first one, not in any particular order, but a triangle basically like this. Okay? And then, of course, like that. And then in a similar way, like that. And then, of course, like this. Now, let's label the vertices. How did I get these? 1, 2, 4, like that. 2, 5, 4, right? 1, 2, and 5, and 1, 4, and 5. Now, that's great, but we can do that again over on this side here, okay? And it's basically the same type of triangles. The only thing is that the vertices are going to be different in terms of which numbers I use. Okay, so first let's draw in those triangles, and now let's label the vertices. Okay, now I used 2, 3, and 5. I used 3, 5, and 6. 2, 3, and 6, and then finally 2, 5, and 6, correct? Yeah. Okay, so I got 8 so far. All right. 8's not one of the answers, so obviously I have to make more. Okay, I see this guy here all the way across. I see another guy like that. And then I've got the same kind of thing but flipped this time. Like this and like this. Okay, now let's label the vertices. All right, it was 1, 3, and 4. And then 1, 3, and 6. And then 1, 4, and 6. And 3, 4, and 6. All right. Any more? I think so. I think there's actually, well, not a lot more, but at least a few more. There's one where you can get the vertice in the middle like that. And then similarly on the bottom like that. So these guys are, let's see here, 1, 3, and 5, and then 2, 4, and 6. Correct? And then these ones, the last ones, not necessarily the hardest, but maybe a few people might miss these. It's these guys here. Let's see here. Hopefully I draw this properly. Running out of space. Can I squeeze it in? I think so. Like that, and then finally like that. All right, so I gotta show you which vertices did I use. I'm sure you figured it out. 2, 3, and 4. 1, 2, and 6. I'm gonna need a little bit more space here, and then I lose my vertices. 3, 4, and 5, and finally 1, 5, and 6. All right, that's a little fun little game here. So how many did I create? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? 18 of them. So 21, the answer is C, and only 4 of these are non-congruent. Okay? 4 of these are non-congruent. Which 4? Well, this guy, this guy, this guy, and this guy. Because all the others are sort of like the same, right? So just understand the difference between distinct, non-congruent, and congruent. Okay? All right, here we go. Next question. A company sells detergent in 3 different sized boxes, small, medium, and large. The medium size costs 50% more than the small size and contains 20% less detergent than the large size. The large size contains twice as much detergent as the small size and costs 30% more than the medium size. Rank the 3 sizes from best to worst by. So we have small, medium, and large. And I'm going to make a little table here. And in my table, I'm going to try to figure out my best buy, my worst buy, and obviously the one that's in the middle. All right, so the first column, or row I should say, is going to be the amount of detergent. That's what I'm going to put in my first one. And the second one, I'm going to talk about the price. And the final one, I will look at my buy in terms of how good it is. So that means we're going to put detergent, amount of detergent, price, and then detergent over price will tell me if it's a good buy, a bad buy, worst buy, all that stuff. Okay, let's go to the question here. The medium size costs 50% more than the small size. So that means if this is P in terms of price, this will be 1.5P. And then it contains 20% less detergent than the large size. So if the large size contains D detergent, this would be 0.8D. Okay? The next sentence, the large size contains twice as much detergent as the small size. So if large size is D detergent, this would be D over 2. And costs 30% more than the medium size. So 30% more would be 1.3 times the medium, which is 1.5P. Okay? And now we got to figure out D over P for each of these. All right, the first one, D over 2 over P. If you put this in a decimal, it'll be 0.5P. All right, the next one, if you do D over P, it'll be 0.8D over 1.5P. And that is 0.53 D over P. This should be D over P, sorry. D over P is telling me how good of a buy it is or not. The more detergent over price ratio, the better of a buy. And then this one, D over P, is just D over 1.3 times 1.5P, like that. And this one is 0.51D over P. So the best buy is the one where I have the highest ratio for D over P, and the worst buy is obviously the lowest. So they want you to rank them from best to worst. So the best one is the highest one, so that's M. The next highest is L, and then the next after that is S. So this is the sizes ranked from best to worst in terms of how good of a buy they are, MLS. So 22 would be E. Isosceles right triangle ABC encloses a semicircle of area 2 pi. The circle has its center O on the hypotenuse AB, and its tangent to the sides AC and BC. What is the area of triangle ABC? So the key to this question, in my opinion, is to extend that square like that. If you do, you will realize something very interesting, and that basically it's just the circle and square cut in half. So you see how that basically is just a square and a circle cut in half, where the circle is inscribed inside the square. All right, no problem. Let's draw our tangent lines. It's basically going to be the radius of the circle. And because they are tangent, they will fall at right angles like that. This is already a right angle since it's a square, and therefore this must be a right angle. And therefore that is essentially a quarter of the square. So that means from here to here is the same as from there to there, since we've cut that side in half. Well, what's interesting is that from here to here is the radius. So we call that R, and therefore since that side is the same, It's also r. It's also the radius, correct? So this is r and this is r. So the area of the triangle ABC would be 1/2 base times height, which is 2r. And then the height is also 2r. So this is 1/2 4r squared, which is 2r squared. Okay? Now we have to figure out the value of r. But that's not a problem because they tell you that the semicircle has an area of 2 pi. So pi r squared divided by 2, it's a semicircle, is 2 pi. So pi r squared is equal to 4 pi. And therefore r squared is equal to 4. And therefore r is equal to 2. All right, plug that back into this guy here. 2 times 2 squared. That gives me 2 times 4, which is 8. And therefore, number 23, the answer is B. A certain calculator has only 2 keys, a +1 and a ×2. When you press one of the keys, the calculator automatically displays the result. For instance, if the calculator originally displayed 9 and you press +1, it would display 10. If you then pressed ×2, it would display 20. Starting with the display 1, what is the fewest number of keystrokes you would need to reach 200? Okay. Well, these are very small numbers actually, right? So something has to happen very quickly for you to get up from 1 all the way to 200. And you obviously are not going to be pressing the +1 button. +1, +1, +1. It's going to be, obviously it's going to take forever, right? It's going to take 200 keystrokes. And we want the fewest number of keystrokes. So we are going to utilize this guy ×2 in a big way. And I'm going to actually go backwards. It makes it easier for me. If I was at 100 and I pressed the ×2, it would get to 200. If I keep going back like that, it's going to make it easier for me to figure out. Now at this point, it would be 12.5, right? 12.5 times 2 would get me up to 25. But I don't like that 12.5 because that's not an integer. And I've got to get eventually down to 1. I'm not going to be able to get to 1 if I'm using non-integers. So when I get to 25, I can't use this +2 guy. But I could use the +1. So that means this could be a 24. And then to get to 25, I use the +1. You see how that works there? Well, 24, I can keep going. That can be a 12, no problem. To get to there, I use the ×2. Just like how I use the ×2 button to get from these guys. ×2 or 2 times, either way, it's same thing. How about 12? Can I go ×2? Yeah. 6 would get me to 12 with the ×2. 3 to 6 would also get me with the ×2. But at this point, I can't do the ×2 because it would be 1.5 and I don't want a non-integer. But I can put 2, and there you go. To get from 1 to 2, well, both of those keys would actually get you to 1 to 2, a +1 or a ×2. To get from 2 to 3, obviously that's a +1. This would do it. So how many keystrokes did I use? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, just got to make sure don't make any mistakes here because these answers are awfully close together. One little mistake and you get the wrong answer. But the answer, I'm confident, is 9, and therefore 24 would be B. A square with side length 2 and a circle share the same center. The total area of the regions that are inside the circle and outside the square is equal to the total area of the regions that are outside the circle and inside the square. What is the radius of the circle? So I blew up this diagram since this diagram is obviously at the heart of this question. First and foremost, let's try to understand what it is that they're asking us or telling us. The total area of the regions that are inside the circle but outside of the square. Well, that would be right here, inside the circle, but outside the square. Okay? And I'll just call each of those guys A. So I've got 4 of them, right? I've got an A here, an A here. They're all equal because of the symmetric nature of this diagram. So 4A represent the regions that are inside the circle and outside the square. And that is equal to the total area of the regions that are outside the circle and inside the square. All right, which regions are those? They're these regions right here. Okay? And I'll call those guys B. That's B, and so on. And there's 4 of those, so 4A equals 4B, and therefore A is equal to B. Okay? So that's the first part of the question. And now I'm going to draw a line from the center of this diagram to the edges like this, all the way to the edge of the circle, like that. And I'm just going to concentrate on that region. Now that region that I drew basically is what? It's a quarter of a circle, correct? And I want you to just pay attention to what I'm really referring to. I'm referring to this region right here. Okay? That's a quarter of a circle, correct? And it's also, if I were to talk about this region, a quarter of a square. Quarter of a circle and a quarter of a square, depending on how I draw it. So there's one region in here that seems to be common to both, and I'll highlight that in orange. It's this region right here. Correct? That's common to both. So I'll call that region, well, might as well just call it region C. All right, now let's talk about this question. The first is the quarter of a circle. Quarter of a circle is pi r squared divided by 4. And you look at this diagram and tell me in terms of our letters A, B, and C, what is it? Well, quarter of the circle is this guy right here. In terms of our letters, what is it? It is C plus A over 2 plus A over 2. Correct? You got the C, obviously, and then you got half of the A's, but you got 2 of them. So that's why it's A over 2 plus A over 2. So that basically becomes C plus A, which is pi r squared over 4. Okay? In a very similar, I'll call that equation 1, and in a very similar way, now let's look at the square right there. That's a quarter of the square. Now we are told, almost forgot about this, that the square has a side length of 2. So if the square has a side length of 2, what is the area of the square? Well, it's 2 times 2. And we have a region that's a quarter of that, so we divide by 4. And then you tell me in terms of our letters, what is the square? It's C plus B, correct? C plus B, like that. All right, now we pretty much are almost done with this question. All we have to do is use equation 1 and equation 2. I will do 1 minus 2. 1 minus equation 2. Pi r squared over 4 minus this guy, which is 2 times 2, which is 4 divided by 4, which is 1. And then on the right side, it would be C plus A minus C minus B. Pi r squared over 4 minus 1. The C's cancel, and then you just get A minus B. But A is equal to B. We established that earlier in the question. So if A is equal to B, A minus B is 0. So we get pi r squared over 4 minus 1 is equal to 0. Put the 1 on the other side, and then therefore pi r squared will be equal to 4, and therefore r squared is equal to 4 over pi, And finally, r would be the square root of that, which is 2 over the square root of pi. 2 over the square root of pi is choice for number 25, choice A, 2 over the square root of pi.